So yes, happy Halloween, 31 October. This assignment posting has actually changed since Friday, since the weekend. It is very much like the 1.2 assignment, except that we've added this additional artifact you need to capture. Page file initial and maximum settings. To do that, you can go to your system information and then click advanced system settings. The other thing I'd tell you is that a cumulative update for October, when it posts, the actual build number with the variant here is 2193. So it's 19045, that's still the same build number, but it's not 2130, it's actually 2193. And that was something that changed over the weekend. So I've updated this, and that's what you're going to have to show when you finish doing your updates, right? So you got to post the October cumulative update for 22H2 after you load the feature update. So you got to bring that up. Now, if you're sitting on a Windows 11 machine, then just be sure that you've posted the October cumulative update for Windows 11. And I will also include Windows 11 version and build number. I'll send that and I'll post it here in case some of you are working with Windows 11. How do you know what the cumulative update is? If you go to the system and go to update and security, and you go to view update history, what you'll see in update history is the cumulative update for 10. So there was more than one. So you see there's actually 3 of these, one that posted earlier in the month, one that posted a few days ago, and a final one. If you're working Windows 11, it's probably the same knowledge base number. KB means knowledge base, right? So whenever you see KB, that's an abbreviation that Microsoft uses for the information, the knowledge base article they put out for reference with everyone worldwide, right? So 501-8482, if you're posting the latest cumulative update for Windows 11, it's likely to be the same set of patches and fixes. I'll verify that to make sure, but in any case, just make sure that what you have matches what's on the requirement here when you post your result. Okay. For Mac users, we've already said that's Ventura. It's version 13, and it may not be long before there's a 13.02 or something like that. Any questions about this assignment? Just wanted to be sure we covered this so that as people, now I'm also going to push back on the deadline here. So even though I leave the deadline as is, I'm going to go ahead and bump back. Can everybody get this done before close of business today? Is that possible? Yes, no, maybe?
Yeah. Yes.
Okay. Does anyone need till the start of class Wednesday? I'm just asking. It'd be great if everyone could get this done soon, because getting this done soon means you're in a good place to start working with VirtualBox, right? Okay. And I'm guessing that there are a fair number of students that already have VirtualBox if they're in other classes I teach. but there's also a fair mix of students who are not because they don't have me in other classes. So I'll go ahead and extend this. If somebody else needs more time, just let me know. So even though the header still shows the original due date, I've pushed this back till midnight tonight. For your virtual devices in RAM, well, wait a minute. I wanted to show you this one more time again. In case you were not with us on Friday, the way to get to this is to go back to your system option in settings, and you go to about, or you can right click File Explorer. You can right click My Computer as it's listed in File Explorer, and it'll bring you to this screen. You want to click Advanced System Settings, and then you're going into, you're moving from this tab to the Advanced tab. You're clicking Performance, then you're clicking the next Advanced tab. Then for virtual memory, you click Change, and you're going to choose a multiple of the size of your RAM. If your RAM is 12 gigabytes large, you're going to multiply by whatever your RAM is in gigabytes, you're going to multiply by 1024. In this case, 12 gigs of RAM for me. I have 12 gigs of RAM on my system. It shows as 11.7, but by the time you finish, it's 12, right? I multiply that by 1024, and that gives me the size of my RAM in megabytes. That's precisely 12,288 megabytes. That's how much RAM I have. If I have adequate hard disk space, and I can take up 12 additional gigs of RAM, I'm going to set the initial and the maximum and then hit set. The moment I do, it's going to take up 12 gigs. In this case, you see, I only have 11.6 gigabytes left. But I already implemented this. Before I implemented this, I actually had 12 plus 11. I had 23.6 gigabytes of free space. So I went ahead and executed that. And I only did it until I did my disk cleanup and my defrag. Many of you completed 1.2 without actually doing this. And we need to make sure everybody does this. Any questions about 4.1 and what's expected completely for 4.1? What do you do if you have a Mac and you need to show a screenshot of an address range for Device Manager and the Resource tab? Does everybody know what I'm talking about here? Kind of, sort of, maybe?
Oh, you mean the like? Wait, say that again.
Here we're asking for you to capture a screenshot of the Device Manager where you click on the Resources tab, and that shows a memory address range. This is something we demonstrated Friday in class. Does everybody remember how to get there?
Yes, but could you like go over it again one more time, just in case?
Okay, was that a request to go over it again real quick?
You
Yeah.
requested.
Okay, sure. I'll be happy to do that. So let's update our list. So if you have File Explorer open, if you open File Explorer and you select the name of your system, like, and it might say this PC or my PC instead of ThinkPad, you're going to right click this, and instead of using properties, you'll go to manage. And alternatively, you can go into the control panel and select computer management under the advanced tools. So what am I saying? You can go the same way into computer management by going typing control panel, and then opening control panel if it's not on your start menu. If you go into administrative tools, you can select computer management. And then computer management will do the same thing, okay? So it'll bring up the same window. That's another way to get to it if you don't do the file explorer thing. When you click on device manager, it's going to enumerate a list of virtual devices that represent the actual physical device. And in order to build a virtual device, a general virtual device that Windows 10 can speak to and all the applications in the world can speak to, we're generalizing all of the different brands and models of devices. So an operating system is creating a stand-in, if you will, for each physical device, the disk drives, the display adapters. You open up one of these, especially the network cards, and if you right click and go to properties, there's an advanced, there's a general tab, but if you go to the resources tab of a device, that's how you get into the resources tab of a device. You select the device, you go into properties, and if you don't see a resources tab, well, that's not a device you can use. That includes a memory address range. Now, in hard drives, that's an exception because it's physical, it's a physical I/O disk with non-volatile memory, and oftentimes hard drives have their own cache. So it's another story. But most of the major components on a system will have this. Processors don't, because processors have built-in memory registers. But a safe bet is either a display adapter, and there's a resources tab, right? So you have a memory range for the display adapter. You have a memory range associated with the network cards. And those memory addresses are reserved. So what we're saying is that your operating system sets aside some of your RAM so that it can create this virtual device that's used with all sorts of different types of applications. That's why, if you've ever wondered, how can so many different applications actually use my display adapter? How can so many different applications use my resources so efficiently? Well, we're not trying to write code to each and every brand and each and every model and each and every type of device. Computer science students, computer science and computer engineering professionals would never have a personal life, then they would never have time for dates, they would never start families and procreate and carry on the cycle of life. They would be extinct by now after 3 generations of writing code for every different brand and model of every different device. Anybody who works in that field would never have a moment of their life to breathe. That's why we do this. That's why operating systems are such a big deal. And we want you to be aware of this. And that's why we're doing in Module 4, this is one of the assignments for Module 4. So any questions? We've walked through that again.
Does it matter which, so I have two options, my GPU, and I have like, so I have a GTX 2060, but I also have an Intel graphics cards as well.
You could use the GTX or the Intel, or you could use one of the network cards. And
Alright.
there are other devices that have resource tabs. You just gotta, you just have to explore a little more. That's all.
Okay.
Especially down here in system devices. In system devices, you have things like the PCI Express components on the motherboard of your laptop or your PC. You have USB ports, right? And so, and then there's actually a separate controller for the USB ports. So here you have the USB ports, and then here you have the controller. Here's a power management device, the battery. Some of these will have a resources tab and some won't. But the most important ones that have to universally speak every language of application that runs in an operating system are the ones that are going to have that memory address range. And that's one reason why before we continue with virtual machines, we want to make sure that you're maximizing the potential of the RAM on your laptop or PC. Okay. I'm glad you asked that question. Any other questions before we clear? So what I'm going to do is, by the way, I did post retakes, the final versions of the module 2 and 3 assessments, and you're supposed to get those done soon. You have some days to, check your facts, look at the reconciliation yet, but we want you to make your final attempts at modules 2 and 3, and then we'll talk about the midterm, because this class voted to engage a midterm. While we're waiting for people to get their stuff in, and I did score and return a lot of items over the weekend. So what you should notice is that I'll update the number of points for earned and possible. So when you go into my grades, I did discover over the weekend too with students, when you reference my grades, you have an option to order by on your app. If you're using a smartphone, you should order by the course order. And when you order by the course order, at the very bottom, earned and possible should be next to each other. And you'll get two basic numbers there, so many earned and so much possible. I'm going to finish updating that right now so that you can see where you stand if you've gotten scores back from all of your submissions. Now, if you haven't finished submissions yet, it'll look like, oh my gosh, I have a low grade. Well, okay, complete your assignments and your submissions, right? And I won't include module 4 stuff yet. I won't include the 2 assignments for module 4. Any questions? Oh, I think in here, yes. Can everybody see this?
Yeah.
Okay. So you have the module 4 study guide, and we have reviewed a lot of the stuff in module 4 already. I've added an addendum, and this addendum is really important because I encountered a really cool, and I think I may have included this resource, other aspects of this resource in other links along the way, but I wanted to intentionally get a little more specific about this one. So when you're talking about the actual digital components, the physical components themselves, and again, this is the module 4 stuff when we're talking about DFFs, digital flip-flops, and system clocks, and memory registers, right? The transistors, originally, your great-grandparents used tubes, vacuum tubes. And they functioned like a valve you could cut on or off. By the time they realized, oh, that's a lot of glass, that's a lot of weird stuff. Materials scientists and physicists and electrical engineers and electronics engineers discovered the wonderful world of transistors. And at a very rudimentary level, when you see a modern CPU and it has so many millions of transistors, it's basically taking this concept and shrinking it down. It is the physical equivalent of a logic gate, right? And the cool part about this website is that there's when you click this link, there's a tabbed option where you can look at how the transistor is built, use for and versus or versus others. And that's a pretty cool thing. We didn't have that in previous years. So I wanted to take the time for module 4 to make sure this was included. That's why it's in the addendum. Now, in a very basic manner, one thing this resource does is it explains very plainly what a transistor, how a transistor works, right? How does it do its job? So a transistor has an emitter. An emitter is something that puts out energy. It emits energy. It releases, an emitter emits things or generates things or releases things. So an emitter is going to put out electrons, and there's a collector on the other side that receives these, right? And there's a gap in between. There's a third component called a base, and it's this base that functions like a switch. So the base has a pin, and the pin can open or close with a little bit of current. So the pin is like a flap that can open or close and serve as like a switch, like the wire and light bulb and battery switch kind of diagram. Everybody remember light bulb? Please say yes. Light bulb, battery, and switch, right? Okay. So if you take that down into a very much smaller level, here you have this contraption. Why does it have 3 pins? One's the emitter, one's the collector, one's the base. Remember the mux? Everyone remember the mux?
Yeah.
Yeah.
Yeah, the mux has a switch built in, allows you to switch between inputs. It's kind of like that, but the concept is a little different. The context is a little different. So what I want you to understand is that there can be cases where you have a mux or a demux. In this case, there's a little bit of current that's applied, and when a current means electrons are flowing, that means it's turned on. When you select the switch and turn it on, it's going to close the gap, allowing the current to flow and allowing this transistor to work. So the context for how this switch and pin work is conceptually a little different than a mux or a demux, okay? Just remember that a mux is a logic gate, and this transistor is physical, right? So we get back to the wire, battery, light bulb, and flip a switch in the middle of that wire. I got to show you this. This is too cool. Oh, and then I also want to mention, we did have in previous modules mention of how this is the symbol that's used for XOR. And there were some cases in the Module 3 solution where students used the symbol for multiplication in their truth table in place of the symbol for XOR. And, you know, it was a finer point. So I basically just said, hey, for future reference, make sure that you use this instead of a round black dot, because that represents multiplication or and, the and logic gate, right? XOR, we've shown you this. You can also have a symbol that looks like this. It's kind of an inverted bar, or sometimes there are abbreviations in other electronics journals, JPQ. In the C programming language, which is a very low level, well, it's a lower level programming language than something like Java, and C is used to create operating systems. So you can do some really interesting, you can do a lot of bit level manipulations with C. This is the symbol that's used for XOR, which is similar to the symbol that's used for exponents in other, like in Excel or scripting languages. So that can get to be a little confusing. But in this context, with logic gates and with the C programming language, this means XOR. What about XNOR? Circle with a dot, or an exclamation point, which means not, and that's in front of this, which means in C, that means XOR. So it's not XOR, or AKA XNOR. If it's not XOR, that's the same as saying XNOR. So this is XNOR in C, and the exclamation point in front means not XOR. In other words, XNOR. Any questions about this? Any questions? All right. Please take the time to take a look at this website in particular. Scroll down. Yeah, this YouTube we've embedded in other. This is one I've already shown you, and it's in another folder. So that should be no surprise to you when you see this. But check this out. Can everybody see and then it says
Yeah.
or? See, it says and then it says or, and then it says not, and then it has NAND. So these symbols, these are electronic transistor components, transistors, resistors, and so on. The thing I want you to understand is that you can take these same basic components, this transistor we were talking about, and if you configure them differently physically, you get the same result as if you take battery, light bulb, wire, and a switch. You can create an and or an or a not, and that's how they work this on a very materials level, right? I think this is cool. This is a really cool way to represent that information and present that information. And for module 4, when we get into the assessment of module 4, don't be surprised if I ask you to identify, okay, is this, what kind of logic gate is created with these transistors? And we'll go into that in more detail before we release the module 4 assessment. We'll add more information to the addendum. Any questions before we clear this?